Welcome to the notes on slope and rate of change. So first, let's start with slope. What does it look like? It is, some people call it the tilt of a line. And the biggest thing that you have to remember is slope actually is rate of change. Okay, so obviously on a graph, it's that tilt, but it's representing a constant rate of change. So as we move forward, always remember that slope equals the rate of change. So here are some examples of slope. Okay, when we're reading these graphs, just remember, we always read these left to right. So when I see uphill, I'm looking at this because I'm looking at the left, and as we go to the right, it's going up. Okay, so left to right. Same with negative. Negative slope, we say, goes downhill. We've got a horizontal slope, which equals 0, and a vertical slope is undefined, which we will show you later why that is. The other thing to remember about slope is the bigger the number, the steeper it is. So if I have a big number here, all right, and I'll put big number, it's going to be steeper. And the smaller the number, all right, the flatter that line is. So just keep that in mind. The same is true for negative slope too. It could be a flat downhill, or if it's a large number, it could be really steep downhill. So keep that in mind as we're working with slope. So now, how do we calculate slope? Here's some definition. Slope of a line, all right, you hear the term rise and run. All right, the rise is the difference of the y values. So y values we refer to as the rise. The run is the difference in the x values. All right, and when we say difference, all right, that's key. That difference, we're going to be using subtraction, which we'll see in a little bit. All right, and then the slope of the line is the ratio of the rise to run. So remember, we're looking at the slope. To find it, we calculate rise over run, change in y over change in x. Couple notes. All right, m is the number we use to represent slope, and change in y over change in x. So just some things to note. If we go up, we go up. If it's positive, all right, we go down if it's a negative for y. And then for the x, all right, left or to the right is positive. And if we have a negative number, we count to the left. So just keep that in mind as we're going through these. So let's take a look at how they calculate the slope. So you pick any 2 points. So if I look at this first point here at the bottom in green, all right, I count the rise, and they literally count up to the next point, up 1, 2, 3. That's how they got a rise of 3. And then from that point, they count over 1, 1, 2. And there's my new point right here. So that's how they've got a run of 2. So when we make our slope, we put it in this ratio. Slope equals 3 over 2. The other cool part about slope is notice every point has that same slope. That's that constant rate of change. And the other thing that's neat is it doesn't matter which 2 points you get, you'll get the same answer. So if I pick that first point at the bottom, and let's say I pick that point all the way at the top, if I count rise over run, we'll get the same ratio. So I'm going to count run first this time just because it's easier to see. So I count over 1, 2, 3, 4, 5, 6. All right, so the run is 6, and then let's count up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the run is 9. So when I calculate slope, which is again m equals, we said its rise is 9 over 6. Well, now you're saying, hey, but the slope of the other one was 3 over 2. Well, slope we always want to reduce. So 9 over 6, when we reduce that, equals 3 over 2. Which is the same as right here. So just an example on slope. Okay, now let's try another example. All right, find the slope of a line. Really easy. Again, slope is change in rise over run. So let's write that down. All right, m equals rise over run. Rise over run. So start at either point. I'm going to start at this point right here. Let's count the rise. So from there we go up 1, 2, 3, 4, 5, 6. All right, up 6. And then the run is over 1, 2, 3. So when we calculate the slope, m equals 6 over 3. Our run was 3. So then that when we reduce that, we want to make it simplified. So the slope is 2. Just count. If they give you a graph, you just count the rise over the run. Let's do one more example. Find the slope of the line through the points -1, 5, and 2, -3. But there's no graph. What do we do? Okay, well, if only we had a slope formula we could use. And there it is. So slope formula, really important. Again, M represents slope. Okay, it equals y2 minus y1 over x2 minus x1. It looks confusing, but you're just subtracting the y, subtracting the x's. What are y2, what are x1, y1, x2, x1? They're ordered pairs. You can see that right here. So they're going to give you 2 points to find the slope. You just take the difference. So let's go back to that original problem. Here it is. What you want to do is you want to label your points. Call one of them x1, call one of them y1. It doesn't matter which one you call x1, but if you call this one x1, this has got to be y1. And then this has got to be, we'll call this one x2, we'll call this one y2. There's our formula right up there. I'll rewrite it so we can see it. All right, M equals, all right, we'll say y2, always a minus sign, y1 over x2 minus x1. Notice the y, the twos, the same subscripts line up. X2, y2, x2, y1, x1. So now we just plug in the points. So that equals, so here we go, y2. Y2 is -3. It's always a minus, okay? And then y1 is 5. So -5, -3 minus 5. And then that's over, x2 is 2. And then it's always a minus. And then x1, now be careful with your signs, it's minus a -1. So now we evaluate this. So on top, -3 minus 5 is -8. And on bottom, 2 minus a -1. Well, these negatives cancel out. So this becomes a +1. So 2 plus 1 is 3. That doesn't reduce. So our final slope is -8/3. The ratio of slope, again, rise over run.